The Rust Programming Language Introduction. Note this edition of the book is the same as the Rust programming language available in print and ebook format from No Starch Press. Welcome to the Rust Programming Language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict through balancing powerful technical capacity and a great developer experience. Rust gives you the option to control low-level details such as memory usage without all the hassle technology associated with such control. Who Rust is for. Rust is ideal for many people for a variety of reasons. Let's look at a few of the most important groups. Teams of developers. Rust is proving to be a productive tool for collaborating among large teams of developers with varying levels of system programming knowledge. Low-level code is prone to a variety of subtle bugs, which in most other languages can be caught only through extensive testing and careful code review by experienced developers. In Rust, the compiler plays a gatekeeper role by refusing to compile code with these elusive bugs, including concurrency bugs. By working alongside the compiler, the team can spend their time focusing on the program's logic rather than chasing down bugs. Rust also brings contemporary developer tools to the system programming world. Cargo. The included dependency manager and build tool makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. Rust FMT ensures a consistent coding style across developers. The Rust language server powers integrated development environment IDE integration for code completion and inline error messages. By using these and other tools in the Rust ecosystem, developers can be productive while writing system-level code. Students. Rust is for students and for those interested in learning about system concepts. Using Rust, many people have learned about topics like operating system development. The community is very welcoming and happy to answer student questions. Through efforts such as this book, the Rust team wants to make systems concepts more accessible to more people, especially those new to programming. Companies. Hundreds of companies, large and small, use Rust in production for a variety of tasks. Those tasks include command line tool, web service, DevOps, tooling, embedded devices, audio and video analysis and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things applications, machine learning, and even major parts of the Firefox web browser. Open source developers. Rust is for people who want to build the Rust programming language, community, developer tools, and libraries. We'd love to have you contribute to the Rust language. People who value speed and stability. Rust is for people who crave speed and stability in a language. By speed, we mean the speed of programs that you can create with Rust and the speed at which Rust lets you write them. The Rust compilers ensure stability through feature additions and refactoring. This is in contrast to the brittle legacy code in languages without these checks. with developers. Let's see, which developers are often afraid to modify. By striving for zero-cost abstractions, higher-level features that compile to lower-level code as fast as code is written manually, Rust endeavors to make safe code and be fast code as well. The Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed and ergonomics. Let's see. Give Rust a try and see if its choices work for you. Who this book is for. This book assumes that you've written code in another programming language but doesn't make any assumptions about which one. We've tried to make the material broadly accessible to those from a wide variety of programming backgrounds. We don't spend a lot of time talking about what programming is or how to think about it. If you're entirely new to programming, you would be better served by reading a book that specifically provides an introduction to programming. Let's see how to use this book. In general, this book assumes that you're reading it in sequence from front to back. Later chapters build on concepts in earlier chapters. The earlier chapters might not delve into details on a topic. We typically revisit the topic in a later chapter. You'll find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you'll learn about an aspect of Rust. In project chapters, we'll build small programs together applying what you've learned so far. Chapters 2, 12, and 20 are project chapters. The rest are concept chapters. Chapter 1 explains how to install Rust, how to write a Hello World program, and how to use Cargo, Rust Package Manager, and Build Tool. Chapter 2 is a hands-on introduction to the Rust language. Here we cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, Chapter 2 is the place for that. At first you might even want to skip Chapter 3, which covers Rust features similar to those of other programming languages, and head straight for Chapter 4 to learn about Rust's ownership system. However, if you're a particularly meticulous learner who prefers to learn every detail before moving on to the next, you might want to skip Chapter 2 and go straight to Chapter 3, returning to Chapter 2 when you'd like to work on a project applying the details you've learned. Chapter 5 discusses structs and methods, and Chapter 6 covers enums, match expressions, and the if-let control flow construct. You use structs and enums to make custom types in Rust. In Chapter 7, you'll learn about Rust's modular system and about privacy rules for organizing your code and its Public Application Programming Interface, API. Chapter 8 discusses the common collection data structures that the standard library provides, such as vectors, strings, and hash maps. Chapter 9 explores Rust's error handling philosophy and technology. Chapter 10 digs into generics, traits, and lifetimes, which give you the power to define code that applies to multiple types. Chapter 11 is all about testing, which even the Rust safety guarantees safety guarantees is necessary to ensure your program's logic is correct. In Chapter 12, We'll build our own implementation of a subset of functionality from the grep command line tool that searches for text within files. For this, we'll use many of the concepts we discussed in the previous chapters. Chapter 13 explores closures and integers, features of Rust that come from functional programming language. In Chapter 14, we'll examine cargo in more depth and talk about the best practices for sharing your libraries with others. Chapter 15 discusses smart pointers and the standard library provides, pointers that the standard library provides and the traits that enable their functionality. In Chapter 16, we'll walk through different models of concurrent programming and talk about how Rust helps you to program in multiple threads fearlessly. Chapter 17 looks at how Rust idioms compare to object-oriented programming principles you might be familiar with. Chapter 18 is a reference on patterns and pattern matching, which are powerful ways of expressing ideas throughout Rust programs. Chapter 19 contains a smorgasbord of advanced topics of interest, including unsafe Rust macros and more about lifetimes, traits, types, functions, and closures. In Chapter 20, we'll complete a project in which we'll implement a low-level multi-thread web server. Finally, some appendixes contain useful information about the language and more reference-like format. Appendix A covers Rust keywords. Appendix B covers Rust operators and symbols. Appendix C covers derivable traits provided by the standard library. Appendix D covers some useful development tools, and Appendix E explains Rust additions. There is no wrong way to read this book. If you want to skip ahead, go for it. You might have to jump back to an earlier chapter if you experience any confusion, but do whatever works for you. An important part of the process of learning Rust is learning how to read the error messages in the compiler displays. These will guide you towards working code, as such, we'll provide many examples that don't compile along with the error messages the compiler will show you in each situation. Know that if you enter and run a random example, it may not compile. Make sure you read the surrounding text to see whether the example you're trying to run is meant to error. Ferris will also help you to distinguish code that isn't meant to work. Ferris, meaning this code does not compile. This code panics. This code block contains unsafe code. This code does not produce a desired behavior. In most situations, we'll lead you to the correct version of any code that doesn't compile. Source code. The source files from which this book is generated can be found on GitHub. Getting started. Let's start your Rust journey. There is a lot to learn, but every journey starts somewhere. In this chapter, we'll discuss installing Rust on Linux, macOS, and Windows, writing a program that prints Hello World, using Cargo, Rust's package manager, and build system. Installation. The first step is to install Rust. We'll download Rust through rustup, a command line tool for managing Rust versions and associated tools. You'll need an internet connection for the download. Note, if you prefer not to use rustup for some reason, please see the Rust installation page for further options. The following steps install the latest stable version of the Rust compiler. Rust stability guarantees ensure that all examples in the book that compile will continue to compile with newer Rust versions. The output may differ slightly between versions because Rust often improves error messages and warnings. In other words, a newer stable version of Rust, you install using these steps should work as expected with the contents of this book. Command line notation. In this chapter and throughout the book, we'll show some commands used in the terminal lines that you should enter in a terminal. All start with $. You don't need to type the $sign character. It indicates the start of each command line. Starts each command. Lines that don't start with the $sign typically show the output of the previous command. Additionally, PowerShell specific examples will use greater than sign rather than $sign. Installing rustup on Linux or macOS. If you're using Linux or macOS, open a terminal and enter the following command: $curl https://rustup.rs-ssf. I'm going to ignore that. The command downloads, the command downloads a script and starts with installation of the rustup tool, which installs the latest stable version of Rust. You might be prompted for the password. If the install is successful, the following line will appear: Rust is installed now. Great. If you prefer, feel free to download the script and inspect it before running it. The installation script automatically adds Rust to your system path after you next log in. If you want to start using Rust right away, instead of restarting your terminal, run the following command in your shell to add Rust to your system path manually. Some code there. Alternatively, you can add the following line to your, and there's some more code. Additionally, you will need a linker of some kind. It's likely one, is already installed, but when you try to compile a Rust program and get errors indicating that a linker could not be executed, that means the linker isn't installed in your system and you'll need to install one manually. C compilers usually come with the correct linker. Check your platform's documentation on how to install a C compiler. Also, with some common Rust packages depend on C code and will need a C compiler, therefore it might be worth installing one now. Installing Rust on Windows. On Windows, go to http://www.rust-language.org/tools/install and follow the instructions for installing Rust. At some point in the installation, you'll receive a message explaining that you will also need C++ builds tools for Visual Studio 2013 or later. The easiest way to acquire the build tools is to install the build tools for Visual Studio 2019. The tools are in the Other Tools and Frameworks section. The rest of this book uses commands that work in both cmd.exe and PowerShell. If there's a specific difference, we'll explain which to use. updating and uninstalling. After you've installed Rust via rustup, updating to the latest version is easy. From your shell, run the following updated script. There's some code to uninstall Rust and rustup to run the following uninstall script from your shell. And some more code there. Troubleshooting. Check whether you have Rust installed correctly. Open a shell and enter this line. And they've got Rust C space dash dash version. You should see the version number, commit hash, and comment date for the latest stable version that has been released in the following format. They've got some code there. If you see this information, you have installed Rust successfully. If you don't see the information on your Windows, check that Rust is in your path system variable. If that's all correct and Rust still isn't working, there are a number of places you can get help. The easiest is Beginners channel on the official Rust Discord. There you can chat with other Rusticians, a silly nickname we call ourselves, who can help you out. Other great resources include the Users Forum and Stack Overflow. Local documentation. The installation of Rust also includes a copy of the documentation locally so you can read it offline. Run rustup-doc to open the local documentation in your browser. Anytime a type or function is provided by the standard library and you are not sure what it does, how to use it, use the Application Programming Interface API documentation to find out. Okay, on to 1.2 Hello World. Now that you've installed Rust, let's write your first program, Rust program. It's traditional when learning a new language to write a little program that prints the text Hello World to the screen, so we'll do the same here. Note, this book assumes basic familiarity with the command line. Rust makes no specific demands about your editing or tooling or where your code lives. So if you prefer to use an integrated development environment, IDE, instead of the command line, feel free to use your favorite IDE. Many IDEs now have some degree of Rust support. Check out the IDE's documentation for details. Recently, the Rust team has been focusing on enabling great IDE support, and progress has been made rapidly on that front. Creating a project directory. You'll start by making a directory to store your Rust code. It doesn't matter to Rust where the code lives, but for the exercise and projects in this book, we suggest making a projects directory in your home directory and keep all your projects there. Open a terminal and enter the following commands to make a projects directory and a directory for the Hello World project within the projects directory. For Linux, macOS, and PowerShell on Windows, enter this. They've got the code right there. You've got make directory, change directory, make directory, change directory. For Windows CMD, enter this. You've got your make directory, change directory, so on. I think the only thing really different is mostly your starting point. Writing and running a Rust program. Next, make a new source file and call it main.rs. Rust files always end with the rs extension. If you are using more than one word in your file name, use an underscore to separate them. For example, hello_rs world.rs rather than hello world.rs. Now open the main RS file you just created and enter the line of code in listing 1-1. Save the file and go back to your terminal window. On Linux or macOS, enter the following commands to compile and run the file. On Windows, enter the command ./main.exe instead of .main, /main. Oh, it's / here and then / here, main. Regardless of your operating system, the string hello world should print to the terminal. If you don't see this output, refer back to the troubleshooting part of the installation section for ways to get help. If the hello world did print, congratulations, you've officially written a Rust program. That makes you a Rust programmer. Welcome. And let's see. Anatomy of a Rust program. Let's review in detail what just happened in your Hello World program. Here's the first piece of the puzzle. FN, main, and your curly brackets. These lines define a function in Rust. The main function is special. It is always the first code that runs in every executable Rust program. The first line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. Also note that the body function is wrapped in curly brackets. Rust requires these around all function bodies. It's a good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. At the time of this writing, an automatic formatter tool called rustfmt is under development. If you want to stick to a standard style Rust across Rust projects, rustfmt will format your code in a particular style. The Rust team plans to eventually include this tool with the standard Rust distribution like Rust C. So depending on when you read this book, it might already be installed in your computer. Let's see, check the online documentation for more details. Inside the main function is the following code: print line ln exclamation mark hello world. This line does all the work in this little program. It prints text to screen. There are 4 important details to notice here. First, Rust's style is to indent with 4 spaces, not tab. So you're going to get 4 spaces before it starts. Second, print line calls a Rust macro. If it called a function instead, it would be entered in as print line without the exclamation mark. We'll discuss Rust macros in more detail in Chapter 19. For now, you just need to know that using an exclamation mark means that you're calling a macro instead of a normal function. Third, you see the hello world string. We pass this string as an argument to print line, and well, I know this doesn't say print line, but that's basically what it is, I believe. And the string is printed to the screen. Fourth, we end the line with a semicolon, which indicates that the expression is over with the next one is ready to begin. Most lines of Rust code end with a semicolon. So we've got the semicolon here. Compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using Rust compiler by entering rustc command and passing it the name of your source file like this: rust stc rustc main.rs. If you have a C or a C++ background, you'll notice that this is similar to GCC or CLANG language. After compiling successfully, Rust outputs a binary executable. On Linux, Mac OS, and PowerShell, on Windows, you'll see the executable by entering the ls command in your shell. On Linux and Mac OS, you'll see these two files. With PowerShell on Windows, you'll see the same three files that you would see using CMD. I've got some code. With CMD on Windows, you would enter the following. This shows the source code file with the RS extension. There it is. With the extension, the executable file main.exe on Windows, but main on all other platforms. And when using Windows, a file containing debugging information with the pdb extension. From here, you can run the main or main.exe file like this. If the main RS was your Hello World program, this line would print Hello World to your terminal. If you're more familiar with a dynamic language such as Ruby, Python, JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead of its time compiled language, meaning you can compile a program and give the executable to somebody else, and they can run it without having Rust installed. If you give somebody a .rb, .py, or .js file, they need to have Ruby, Python, or JavaScript implementation installed respectively. But in those languages, you only need one command to compile and run your program. Everything is a trade-off in language and design. Just compiling with rustc is fine for simple programs. But as your program grows, you'll want to manage all options and make it easy to share your code. Next, we'll introduce you to the Cargo tool, which will help you write real-world Rust programs. Okay, now we're on 1.3. Hello, Cargo. Cargo is Rust's built system and package manager. Most Rustians use the tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call libraries your code needs dependencies. The simplest Rust programs, like the ones we've written so far, don't have any dependencies. So if we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies. And if you start a project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you are using Cargo too. Cargo comes installed with Rust if you use the official installers discussed in the installation section. If you installed Rust through some other means, check whether Cargo is installed by entering the following into your terminal. If you see a version number, you have it. If you see an error such as command not found, look at the documentation for your method of installation to determine how to install Cargo separately. Creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your projects directory or wherever you decided to store your code. Then on any operating system, run the following. The first command creates a new directory called Hello Cargo. We have named our project hello_cargo, and Cargo creates its files in a directory of the same name. Go to the hello_cargo directory and list the files. You'll see that Cargo has generated 2 files and 1 directory for us. A Cargo toml file and a source src directory with a main.rs file inside. It has also initialized a new Git repository with a .git ignore file. Note, Git is a common version control system. You can change Cargo new to different version control system or no version control by using the --vcs flag. Run Cargo new space --help to see the available options. Open Cargo toml in your text editor of choice. It should look similar to the code in listing 1-2, file name Cargo toml. Then they give you some code. Listing 1-2 contents of Cargo toml generated by Cargo new. This file is the toml, Tom's Obvious Minimal Language format, which is Cargo's configuration format. The first line package is a section heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 4 lines set the configuration information Cargo needs to compile our program. The name, version, who wrote it, and the edition of Rust to use. Cargo gets your name and your email information from your environment. So if that information is not correct, fix the information now and save the file. We'll talk about the edition key in Appendix E. The last line, dependencies, is the start of a section for you to list any project's dependencies. In Rust packages of code are referred to as crates. We do not need any other crates for this project, but we will in the first project in Chapter 2. So we'll use this dependencies section then. Now open src/main.rs to take a look. File name. Some more code. Cargo has generated a Hello World program for you, just like the one we wrote in listing 1-1. So far, the differences between our previous project and the project Cargo generates are that Cargo placed the code in the source directory and we have a Cargo toml configuration file in the top directory. Cargo expects the source files to live inside the source directory. The top level project directory is just for README files, license information, configuration files, and anything else not related to your code. Using Cargo helps you to organize your projects. There's a place for everything and everything in its place. If you start a project that doesn't use Cargo, as we did with the Hello World project, you can convert it to a project that does use Cargo. Move the project code into the source directory and create the appropriate cargo toml file. Build and running a cargo project. Now let's look at what's different when we build and run the Hello World program with cargo from your hello_cargo directory. Build your project by entering the following command. This command creates an executable file in target/debug/hello_cargo, or rather than in your current directory, you can run the executable with this command. I give the command. If all goes well, Hello World should print in the terminal. Running cargo build for the first time also causes cargo to create a new file in the top level, cargo lock. This file keeps track of the exact versions of dependencies in your project. The project doesn't have, this project doesn't have dependencies, so the file is a bit sparse. You won't ever need to change the file manually. Cargo manages its contents for you. We just built a project with cargo build and ran it with /target/debug/hello_cargo, but we can also use cargo run to compile the code and then run the resulting executable all in one command. I've got some more commands. Notice that this time we didn't see output indicating that cargo was compiling. Hello cargo. Cargo figured out that the files hadn't changed. So it just ran, the binary. If you had modified your source code, cargo would have rebuilt the project before running it, and you would have seen this output. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but not produce any executable. Okay, why would you not want an executable? Often, cargo check is much faster than cargo build because it skips the step of producing an executable. If you're continuously checking your work while writing the code, using cargo check will speed up the process. As such, many Rustians run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. Let's recap what we've learned so far about cargo. We can build a project using cargo build or cargo check. We can build and run a project in one step using cargo run. Instead of saving the result of the build in the same directory as our code, cargo stores it in the target/debug directory. An additional advantage of using cargo is that the commands are the same no matter which operating system you're working on. So at this point, we'll no longer provide specific information about Linux and macOS versus Windows. Building for release. When your project is finally ready for release, you can use cargo build --release to compile it with optimizations. This command will create an executable in target/release instead of target/debug. The optimizations make your Rust code even faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for developers. Let's see, when you want to build quickly and often, and another for building the final program. You'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If that Let's see, if you're benchmarking your code's runtime, be sure to run cargo build space -- release and benchmark with the executable in target / release. Cargo as convention. With simple projects, Cargo doesn't provide a lot of value over just Rust C, but it will prove its worth as your programs become more intricate. With complex projects composed of multiple crates, it's much easier to let Cargo coordinate the build. Even though the hello underscore cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following command to check out the code using git. Change to that project's directory and build. For more information about Cargo, check out its documentation. Summary. You're already off to a great start on your Rust journey. In this chapter, you've learned how to install the latest stable version of Rust using rustup, update to a newer version of Rust, newer Rust version, open locally installed documentation, write and run a Hello World program using Rust C directly, create and run a new project using the conventions of Cargo. This is a great time to build a more substantial part, to get used to reading and writing Rust code. So in Chapter 2, we'll build a guessing game program. If you'd rather start by learning how common programming concepts work in Rust, see Chapter 3 and then return to Chapter 2.